In previous session, we have discussed about domain and range of inverse trigonometric function. In this session, we are going to solve the problems of exercise 1 of inverse trigonometric function. Before going to exercise, we have to learn some properties of inverse trigonometric function. So, the properties are properties of inverse trigonometric functions. First property is sine inverse of sine theta that equals to theta. Second one, cos inverse of cos theta equals to theta. Third one, tan inverse of tan theta equals to theta. Fourth one, secant inverse of secant theta equals to theta. Next, cosecant inverse of cosecant theta equals to theta. Cot inverse of cot theta equals to theta. That means sine inverse, sine gets cancelled, then theta will remains. Next one, seventh property, sine inverse of minus x equals to minus of sine inverse of x. Tan inverse of minus x equals to minus of tan inverse of x. Secant inverse of minus x equals to pi minus secant inverse of x. Cosecant inverse of minus x equals to minus of cosecant inverse of x. Cos inverse of minus x equals to pi minus cos inverse of x. Cot inverse of minus x equals to pi minus cot inverse of x. Sin inverse of x plus cos inverse of x that equals to pi by 2. Tan inverse of x plus cot inverse of x that equals to pi by 2. Secant inverse of x plus cosecant inverse of x that equals to pi by 2. Next, tan inverse of x plus tan inverse of y that equals to tan inverse of x plus y by 1 minus x into y. Next one, tan inverse of x minus tan inverse of y that equals to tan inverse of x minus y by 1 plus x into y. Next one, I'm writing here. Eight into 1. Two into tan inverse of x equals to tan inverse of 2x by 1 minus x square, that is equals to, in terms of sine inverse of 2x by 1 plus x square. In terms of cos is cos inverse of 1 minus x square by 1 plus x square. So we have here three formulas for 2 into tan inverse of x. 2 into tan inverse of x having three formulas, that is in terms of tan, in terms of sine, in terms of cos. Next one, two into sine inverse of x equals to sine inverse of 2x into under root of 1 minus x square. 2 into cos inverse of x equals to cos inverse of 2x square minus 1. Next one, 3 into sine inverse of x equals to sine inverse of 3x minus 4x cube. Next, 3 into cos inverse of x equals to cos inverse of 4x cube minus 3x. 3 into tan inverse of x equals to tan inverse of 3x minus x cube by 1 minus 3x square. Sin 3 theta, that equals to 3 sin theta minus 4 sin cube theta. Cos 3 theta equals to 4 cos cube theta minus 3 cos theta. Sin 2 theta equals to 2 sin theta into cos theta. That same formula is in terms of tan, is 2 tan theta by 1 plus tan square theta. Next, cos 2 theta equals to cos square theta minus sin square theta, and 2 cos square theta minus 1, and 1 minus 2 sin square theta, and 1 minus tan square theta by 1 plus tan square theta. So we have here for cos 2 theta, cos square theta minus sin square theta, 2 cos square theta minus 1, 1 minus 2 sin square theta, and the final formula is 1 minus tan square theta by 1 plus tan square theta. Next, next 28th formula, tan 3 theta, that equals to 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Next, 1 minus cos theta, that equals to 2 sine square theta by 2. 1 plus cos theta, that equals to 2 cos square theta by 2. Next one, 1 minus cos theta by 1 plus cos theta, that equals to tan square theta by 2. Okay, these are the formulas which are useful in solving the problems of inverse trigonometric functions. Now I am going to solve the exercise 1. In exercise 1, first bit is, first question, find the principal value of the following questions. Find the principal value of the following questions. In that first question, we have 10 bits, 10 questions. First one is sine inverse of minus 1 by 2. Sine inverse of minus 1 by 2. Solution. First of all, let us assume the given total function is, let theta. Let theta equals to sine inverse of minus 1 by 2. Then sine theta equals to minus 1 by 2. Or you can apply the formula here, that is, since sine inverse of minus x equals to minus of sine inverse of x, you can apply this formula also here. So then this term, this expression becomes theta equals to minus of sine inverse of 1 by 2. According to this formula, sine inverse of minus x equals to minus of sine inverse of x. Same, sine inverse of minus x, in place of x we have 1 by 2. So sine inverse of minus x equals to minus of sine inverse of x. Minus of sine inverse of 1 by 2. Now you can raise one question in your mind, that is, at which degree in sine function the value becomes 1 by 2. At which degree in sine function the value becomes 1 by 2. Sine 30, 1 by 2. So in place of 1 by 2, you can write sine 30. Sine 30. In place of 1 by 2, sine 30. Sine 30, 1 by 2. So theta equals to minus of sine inverse of sine 30 can be written as pi by 6. So we have one property, that is, first property, sine inverse of sine theta, that equals to theta. So here sine inverse of sine theta, that 5 by 6 is a theta. So you can write as theta. So theta equals to minus of pi by 6. This is our required value. So you check whether this value lies in between that particular range or not. Sine range. Sine range is minus pi by 2 to pi by 2. Closed interval. So you check whether this value sine minus 30 is in the range of this value or this range or not. So sine minus 30 is in the range of this sine range, minus pi by 2 to pi by 2. So simply we say that the principal value of this function is minus 5 by 6. Now you can write one term here, that is we know that the range of principal value of sine inverse of x is minus pi by 2 to pi by 2. Therefore, theta equals to minus pi by 6 is belongs to this range pi by 2 to pi by 2. Okay. Therefore, finally we conclude that therefore the principal value of sine inverse of minus 1 by 2 is minus pi by 6. This is the solution for first question. Next, I am going for second question. That is, find the principal value of cos inverse of root 3 by 2. Cos inverse of root 3 by 2. Solution. Let us assume the given function is a theta. So once observe here, we don't have negative term here, so you don't apply the formula. In previous question you have the negative term here, that's why we applied the formula, that is sine inverse of minus x equals to minus of sine inverse of x. But we don't have negative term, so you directly solve this question. Theta equals to cos inverse of root 3 by 2, that means cos 30. Cos 30 root 3 by 2. In place of root 3 by 2, you can write cos 30 pi by 6. So theta equals to pi by 6. We know that the range of principal value of cos inverse of x is 0 to pi. The range of cos function is 0 to pi. So theta equals to pi by 6 is belongs to 0 to pi. Therefore, the principal value of cos inverse of root 3 by 2 is pi by 6. Simple question. Next, third question is similar to first and second question. Fourth question also similar to first and second question. Now I am going to explain fifth question. Cos inverse of minus 1 by 2. In second question we don't have negative term, that's why we apply the solution directly. But here in cos term we have negative symbol. So now you see how we can solve this problem. Solution. Let theta equals to cos inverse of minus 1 by 2. Here we have negative symbol. If we have negative term here, then we apply the formula cos inverse of minus x equals to pi minus cos inverse of x. Already I given the formulas for all these things. So cos inverse of minus x equals to pi minus cos inverse of x. So now right here theta equals to, now you apply this formula. So cos inverse of minus 1 by 2 equals to pi minus cos inverse of 1 by 2. According to this formula, cos inverse of minus x, cos inverse of minus 1 by 2, in place of x we have 1 by 2 minus that equals to pi minus cos inverse of x. So theta equals to pi minus cos inverse of x. X means 1 by 2. So theta equals to pi minus, at which degree in cos function, at which degree in cos function the value becomes 1 by 2. Cos 60, 1 by 2. So you can write cos inverse of, in place of 1 by 2, cos 60 pi by 3. Okay, then theta equals to pi minus cos inverse of cos theta. Since cos inverse of cos theta equals to theta, so according to this formula, cos inverse of cos theta, cos inverse of cos pi by 3, that gives pi by 3. So theta equals to, now take LCM here, 3 pi minus pi, that is theta equals to 2 pi by 3. Now we check whether this angle, theta angle, lies in between cos range or not. We know the cos range 0 to pi. What is the value of 2 pi by 3? 2 pi 180 by 3, that equals to 60, 120. Now pi value 180, 2 to 180 by 3, that is 120. So check whether this 120 lies between 0 to pi. 0 to pi means pi value 180. 0 to 180. In between 0 to 180 we have 120. Therefore our principal value is 2 pi by 3. So we know that the range of principal value of cos inverse of x is 0 to pi. Therefore theta equals to 2 pi by 3 is belongs to 0 to pi. Therefore the principal value of cos inverse of minus 1 by 2 is 2 pi by 3. Okay. So next questions are similar to these questions. Okay. Next I am going to solve 11th question. 11th question. Find the values of the following question from 11 to 14. From 11 to 14. Question number 11 to 14. Find the values of the following questions. So 11th question is tan inverse of 1 plus cos inverse of 1 by 2 plus sin inverse of minus 1 by 2. Solution. The given expression is not in the form of standard form, so we can take separate terms and solve separately and finally add all these three terms. Then you will get the final answer. So now I am taking first term, that is tan inverse of 1. Let x equals to tan inverse of 1. So x equals to tan inverse of tan pi by 4. In place of 1 I am writing here pi by 4. Why? Because tan pi by 4 equals to 1. Tan inverse tan inverse. Then x equals to pi by 4. So therefore tan inverse of 1 equals to 5 by 4. As in this is first equation. Okay. Next, I am taking second term, that is let cos inverse of minus 1 by 2 equals to, assume y, then y equals to cos inverse of minus 1 by 2, that is y equals to y minus cos inverse of 1 by 2, because we know that cos inverse of minus x equals to y minus cos inverse of x, that equals to y equals to y minus cos inverse of cos pi by 3. ठीक है, cos 60 1 by 2, so y equals to pi minus pi by 3, so that equals to 3 pi minus pi by 3, then y equals to 2 pi by 3. Therefore cos inverse of minus 1 by 2 equals to 2 pi by 3. This is second equation. Now we take third term, that is sin inverse of minus 1 by 2. So third term is sin inverse of minus 1 by 2, that equals to, assume that is z, then z equals to sin inverse of minus 1 by 2. Then you can write in this function as minus of sin inverse of 1 by 2. So z equals to minus of sin. At which degree in sin function the value becomes 1 by 2, that equals to sin 30 1 by 2. You can write this function as sin pi by 6. So z equals to minus pi by 6. Therefore sin inverse of minus 1 by 2 equals to minus pi by 6. Assume this is third equation. Therefore final tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2 is equal to, add these three terms, first equation, second equation and third equation, that is x plus y plus z, that equals to x value pi by 4, y value 2 pi by 3 minus pi by 6. Now take LCM here, that is 4, 3, 6, LCM is 12. 4 how many terms cancel? 3 times, 3 pi plus 8 5 minus 2 pi, that equals to 11 pi minus 2 pi by 12, that equals to 9 pi. 9 pi by 12. 3 3 cancel, 3 4 cancel. So the final answer is 3 pi by 4. Okay children, remaining 3 questions I am giving for you homework. Okay, thank you.